Hey, I'm Brian. Welcome to UV Squared Woodworks. Today I'm going to tackle a very common problem in the wood shop, and that's dust collection for my miter saw. I have a small shop. It's half of a two-car garage, but honestly, I've taken over both halves, and my wife hasn't parked in here in about a year. She's getting a little frustrated. So the next project is going to be trying to clean this place up and so that I can work more efficiently as well as give her a parking spot back. Um, Today I'm going to try to mitigate the mess in the first place or part of the mess in the first place. I don't have a dedicated miter station. I just set it up on my assembly table slash outfeed table for my table saw. And in not having a dedicated place for it, I don't really have a good solution for dust collection. Today that changes. Usually it just sprays sawdust everywhere and I end up having to clean it up later. Today I'm going to design a um, dust port in Fusion 360. I'm going to 3D print that on my Bambu Labs X1 carbon printer, and um, we're going to see if we can mitigate this problem as best as possible. So come along on the journey as I get this project started, and I'll show you how I do it. Does this ever happen to you?
Alright, so here we are in Fusion. As you can tell from that last clip, I've got a bit of a dust problem. So, going to um, go ahead and start a new project, and we'll just call it Dust Port. And this is about the fourth time that I've tried this, so I'll call it version 4. So I'm going to start a new sketch. We're going to go on the front plane, and we'll activate the line tool. And we're going to draw our basic shape here. The measurements at this point are just pretty much arbitrary. We'll dimension it here in just a moment. So let's get our dimensions straight. So the 4-inch dust collection connector that I have for the Dust Right Quick Connect is 105.5 millimeters. So I'm going to draw half of this to revolve the full part. So half of 105.5 is 52.75 millimeters. There is a slight taper, and at the top of that taper, we're going to just go up a millimeter. So half of that will be 53.25 millimeters. And then this is actually going to be 40 millimeters high. So at the top here, this taper is also going to be 40 millimeters high. The top is 57 millimeters, or the dust port on my saw is 57 millimeters. So half of that is going to be 28.5 millimeters. And then it also has a slight taper, and it's 29.5, so 59.75. Um, half of that is 29.5. And then the last measurement, this is going to be 100 millimeters. That's going to give us uh, fairly good um, size. It's going to be easy to print. It's not going to waste a whole bunch of filament in the transition, but we do need this angle to be somewhat sharp so that we can print it without supports. So I'm going to go ahead and finish the sketch. I'm going to activate the revolve tool, and I'm going to revolve around this axis. And as you can see, Fusion does a good job of just um, creating the part. So this is a solid part. We need to make it hollow. we're going to have a 4.5 millimeter wall thickness. So I'm going to modify and activate the shell command. I'm going to open up the bottom and the top and give it 4.5 millimeter wall thickness. And as you can see, we now have a hollow part. So now we're going to do 4 millimeter fillets on the outside and the inside, and it's just going to break that sharp edge. The enemy of suction loss, or the enemy of suction, is sharp corners. So I know that this is basically a 40 degree angle, so it's not terrible, but I just want to break that corner. So we're going to go with a 4 millimeter fillet there. And then just on this outside edge, we're going to go with a 1 millimeter fillet. And that's basically the part. One thing that I do want to do, and this is completely optional, I like to put my logo on things. So I'm going to create an offset plane, again on the front. We're going to offset that 55 millimeters. And we're going to go OK. We're going to insert the DXF file on that offset plane, and I'm just going to insert my logo. For some reason it likes to import upside down, so I'm going to select the sketch object and just going to rotate that 180 degrees. And then we're going to move this over to the 52, 2.75, which is the center. And we're going to go up 12.5 millimeters and put it basically in the middle. All right, so now I want to emboss that logo onto the face. So we're going to choose the sketch profile to emboss. We're going to actually do a deboss, and we're going to select this face. And 2 millimeters is a little bit too deep, so I'm going to go 0.75. And then you can see there that we have the completed part with the logo. It's ready to print. Just gonna modify the appearance. Instead of it being a metal, we'll go with a plastic, and we'll give it a kind of a black finish. That's going to be fine. It still gives you an idea of what it's going to look like when it's printed. All right, so let's go ahead and save. We will export this as an STL file. And then I will open that in Bambu Studio. I'm going to change my infill to 25%. And just personal preference, I'm going to change the seam position to the back. Everything else, I have a preset settings for my PETG, so it's ready to slice. As you can see, there's not going to be much issue with um, overhang. Sometimes PETG doesn't get along very well with overhangs, so there may be some stringing, but it's not going to affect the print. All right, so 3 hours and 9 minutes. Going to cost about $3 in filament. Um, I would imagine that if I were to find something on a shelf in a store somewhere, that there would probably be about $20 for this part. But I've looked and I've not been able to find anything that goes from a Ridgid miter saw directly to the Dust Right Quick Connect hose. So um, this is going to be a much better option for me. So let's go ahead and print the part. I will put the uh, time lapse up while you're waiting. I'll see you in about 15 seconds your time, and um, I'll show you how it came out.
All right, so here's the part that we 3D printed. It took about 3 hours. I printed it in PETG filament. Um, it is very rigid. I can squeeze it a little bit, and you can see some of the stringing from the unsupported overhangs. That's going to um, cause no inherent effect um, on the dust collection whatsoever. Um, it's a miter saw. There's going to be some dust. The problem is that I'm just spraying it everywhere. So anything is better than nothing. So let's put it in the saw and see how it works. So just before I made that cut, I cleaned off the saw, and you can see how much dust is left after making that one cut by actually using dust collection. Very little actually escaped the dust port. So as you can see, I may not have solved my dust collection problem for the miter saw 100%, but I've definitely improved my situation. If you'd like to make this project for yourself, I'll leave a link in the description below for the files that will be posted on MakerWorld and on Printables. If you feel that I've earned it, go ahead and hit that like button and subscribe to my channel. I've got a lot of great projects coming up this year, and I'd love to take you along on the journey with me. Thank you for watching, and I'll see you next time in the woodshop.